Imagine living in a house where every time you want a glass of water, a massive corporation hundreds of miles away has to pipe it directly to you.
Right, and you have to pay for every single drop.
Exactly. You pay for it, you wait for the pressure to build, and the company gets to inspect your glass before you're even allowed to drink. I mean, it sounds insane for water, but that is essentially how we treat artificial intelligence today.
So, okay, let's unpack this. We're doing a deep dive into this major shift from cloud-heavy AI to edge AI.
Yeah, and our primary source for this is the new book, Ling 3.0 Tiny, the developer and engineer guide to ultra compact, high efficiency edge AI.
Honestly, the cover art alone sets the tone immediately. It's this metallic robot face with these intense glowing blue
It
eyes,
really gives off that distinct feeling that the AI is, waking up right inside the machine sitting in front of you.
which makes sense because to understand why we need a new kind of AI, we really have to look at the massive friction of the current cloud-first model.
Oh, definitely. The network latency, the API costs just constantly adding up, and obviously the privacy issues of sending your personal data to some remote server.
Right. What's fascinating here is how Ling 3.0 Tiny completely bypasses that centralized system. We are talking about a sub-billion parameter small language model, or SLM, that runs entirely off-grid.
So totally disconnected.
Entirely.
Yeah.
You get sub-100 millisecond response times, zero token costs, and absolute data privacy, because the data literally never leaves your device.
Okay, I have to push back here for a second. The entire industry narrative has been, well, bigger is better. Trillions of parameters equal better reasoning.
That has been the standard line, yeah.
Right. So if you cram a language model into a smartphone or like a $60 Raspberry Pi, how does it not just lobotomize the AI? Doesn't shrinking a model that much destroy its logic or cause it to hallucinate constantly?
I mean, it seems like it should, but the secret is this mathematical process called quantization.
Quantization. Okay.
Yes, specifically, the book highlights formats like INT4 and GGUF. To understand how it works without destroying the intelligence, think about shrinking a high-resolution digital photograph.
Like down to a much smaller JPEG format.
Exactly. You lose some of the ultrafine microscopic pixel detail.
But you can still clearly see the overall picture.
Yes, exactly that principle. In AI terms, a massive model uses highly precise floating point numbers for its weights. Quantization maps those precise weights down to much lower precision integers.
So it drops the microscopic decimal details?
Right, but it preserves the relative mathematical distances between the core concepts. The AI retains its underlying reasoning capabilities because the structural shape of its knowledge hasn't changed, even if the precision of the underlying numbers has.
Oh, wow. So the intelligence is essentially the relationship between the data points, not the endless decimal places of the data points themselves.
Spot on. And that explains how they can compress a 1.6 gigabyte model down to roughly 450 megabytes.
That is incredibly small.
It is, and at that size, it unlocks a massive hardware advantage. Instead of needing giant GPU clusters, a 450 megabyte model can just sit directly in Apple Silicon's unified memory.
Or it leverages Oron Neon instructions to run lightning fast on highly constrained hardware.
Yeah. Exactly. Barely making a dent in your battery life or thermal output.
So, what does this all mean for someone actually building practical tools with this? If I have this ultra fast AI on my phone, but it is completely disconnected from the internet, isn't its actual knowledge severely limited?
Well, not if you give it local context. If we connect this to the bigger picture, Ling 3.0 Tiny relies on a technique called micro-RAG.
Retrieval augmented generation.
Right. But instead of searching the web, it queries local embedded databases. It can instantly scan through your personal PDFs, your local emails, or your device's telemetry logs.
That is wild. It becomes a highly personalized agent that knows everything about your specific context without ever broadcasting a single byte of it to the web.
Which brings us to its second real-world superpower, acting within a hybrid edge cloud architecture. The tiny edge model sits at the front door as a Tier 1 triage agent, handling about 80% of routine tasks locally.
But how does it actually know when it's out of its depth? If it's handling triage, there has to be a mechanism for it to realize a task is too complex, right?
Yeah, it relies on semantic routing and confidence scoring. When you ask a question, the edge model instantly calculates a mathematical confidence score for its own potential answer.
Okay.
If that score falls below a strict threshold,
Like, say you ask it to write highly complex, multi-threaded code.
exactly. It recognizes its own limitations and seamlessly escalates that specific query up to a massive cloud model.
So it's the best of both worlds. You get the speed, privacy, and zero-cost benefits of local AI for the daily grind, and you only pay for the heavy lifting cloud AI when it's strictly necessary.
Exactly.
I mean, this fundamentally democratizes how you interact with artificial intelligence.
Yeah.
You no longer have to endlessly rent intelligence. You can actually own it securely on the hardware you already have. You finally get your own well.
Which leaves us with a really fascinating scenario to think about. Well, if every single device you own, from your smart thermostat to your phone, starts running its own autonomous local AI, and those devices start communicating with each other in a decentralized mesh network, what happens to our traditional reliance on a centralized internet?
That is a wild thought to leave off on. We will let you chew on that one. Thanks for joining this deep dive.